triangle ABC is 81 centimeter square. Its side length AB is 18 and its side length AC is 15 centimeter. And now our task is to calculate the area of this circle. Please don't forget to give a thumbs up and subscribe. Please keep in mind that this figure may not be 100% true to the scale. Let's go ahead and get started. And here's our very first step. I have dropped a perpendicular CD on this line AB, as you can see. And now let me go ahead and label this perpendicular CD as lowercase h, and h stands for height of this blue triangle. And here's our next step. Let's focus on this triangle ABC. And now let's recall the area of a triangle formula. Area equals to a half times base times height. And in our case, the area of this blue triangle ABC is 81. Its base is 18 and the height is h. So let's go ahead and fill in the blanks in this formula. Our area is 81 equals to a half times our base is 18 times our height is h. And now we are going to solve for h. 81 equal to, on the right hand side, 18 divided by 2 is 9 times h. Let's divide both sides by 9. So therefore our h value turns out to be 9 centimeter. So thus our height h turns out to be 9 centimeter. And now let's focus on this right triangle ADC, whose side lengths are 9 and this longest leg is 15. And now we are going to calculate this side length AD. And now let's recall the Pythagorean triplets 3, 4 and 5. Let's go ahead and multiply all these numbers by 3. Then after a multiplication of 3, this 3 is going to become 9, 4 is going to become 12 and 5 is going to become 15. So in our case we got this 9 and this is 15. So therefore this unknown side length AD is going to be 12 centimeter. And now we know that this whole chord AB is 18. This length is 12. So therefore this length BD is going to be 18 minus 12 is going to give us 6 centimeter. And here's our next step. I have drawn this diameter CE that passes through this center O. And then I have connected this point E with this point A, as you can see. And now let's recall the Thales theorem. According to this theorem, if E, A and C are three distinct points on the circle where the line EC is a diameter, then the angle EAC is a right angle. As you can see in our diagram, we got CAE 3 points on this circle, and this EC is a diameter, so no wonder this angle is 90 degrees. So therefore we conclude that this triangle EAC is a right triangle. And now let's recall inscribed angles theorem. According to this theorem, inscribed angle that intercept the very same arc are congruent. And now let's focus on these two angles, angle E and this angle B. And both of these angles make this very same arc, as you can see. So therefore we conclude that these angle AEC and this angle DBC are congruent. And furthermore, this angle in this triangle EAC and this another angle in this triangle BDC are congruent as well, since these other angle is 90 degrees. So therefore we conclude that these triangle EAC and this other triangle BDC are similar triangles according to angle similarity theorem. And now let me go ahead and label this side length AE as our X. And now we are going to solve for this x. So therefore we are going to have a proportion in these two similar triangles. In other words, the ratio of x and 15 is going to be equal to the ratio of 6 and 9. So therefore let me go ahead and write down x divided by 15 equal to 6 divided by 9. Let me go ahead and multiply both sides by 15 to isolate x, and here 15 and 15 is gone, so x turns out to be equal to 6 times 15 is 90. 90 divided by 9 is going to give us 10 centimeter. So therefore our this length AE turns out to be 10 centimeter. And here's our next step. Let's focus on this right triangle EAC, whose side lengths are 15 and 10. And now we are going to use the Pythagorean theorem to calculate this side length EC. And here's our Pythagorean theorem: a square plus b square equal to c square. Let me go ahead and call our longest leg as our side C. I'm going to call this side A and this side lowercase b. So let's go ahead and fill in the blanks in this Pythagorean formula. A in our case 10, so it's going to become 10 square plus b is 15 square equal to c square. So therefore our c square value turns out to be 325. Let me go ahead and undo this square by taking a square root on both sides. So therefore our length c turns out to be square root of 325. So thus we can see that this EC length turns out to be square root of 325, as you can see over here, and that is also our diameter. So therefore the radius of this circle is going to be half of this diameter. Let me go ahead and label radius r equals to square root of 325 divided by 2. And here's our final step. Let's go ahead and calculate the area of this circle. And now let's recall the area of a circle formula. Area equals to pi r square. In our case, our radius r is square root of 325 divided by 2. Let's go ahead and fill in the blanks. So the area of this circle is going to be pi times r, in our case is square root of 325 divided by 2 whole square. And if we simplify the right hand side, area of this circle is going to be 325 pi divided by 4, and that is going to be equal to 81.25 pi. So thus the area of this circle turns out to be 81.25 pi centimeter square. Thanks for watching, and please don't forget to subscribe to my channel for more exciting videos. Bye.